So, what questions from this test do you have?
When do you cross multiply fractions? Is that
When there's an equals. When is the proportion?
okay? So doing the same thing.
Oh well. What other questions?
Number 9, H and C.
9, H, and C.
Wait, no, H and B.
H and B. Okay. Okay. No calculator. 9B. All right, we're supposed to, without a calculator, find the sine of 2 pi over 3. No, you're free. Okay. So, what should we do?
Look at the chart and then.
I would not start there, but I would go there eventually.
Would you convert it to degrees?
Definitely not. Heck
Well, then
no.
I don't know what else our options are.
So, I would make a little tiny sketch of where 2 pi over 3 is, so I can figure out what quadrant it's in. Figure out,
Good idea.
because 2 pi over 3 is not on the chart. So we have to go back to a reference angle that will be on the chart, right? So, where is 2 pi over 3?
2/3, so it's in the
It's in
1/3.
the first quadrant.
No,
Wait,
It's in the second one because
it is.
it's more than one.
This is pi, yeah? So it's 2/3 of pi. So it's about right there. That's 2 pi over 3. So what we need to know to get to a chart is what is the reference angle?
Oh, that's what a reference angle was. I forgot about that while I was taking the test.
So what's the reference angle?
Pi minus 2 pi over 3.
Yes, it is pi minus 2 pi over 3, which would be what?
1/3 pi.
Yeah, pi over 3.
Pi over
Okay. What's the sine of pi over 3?
60 degrees.
What is the sine of pi over 3?
Square root.
Oh wait, no, that's in the chart.
Square root of 3 over 2.
Wait, no, it's not.
Is sine positive or negative in quadrant 2?
Positive.
See, I promise I know these things. I just don't think as fast as they do. I promise I understand.
So the next unit, I will warn you ahead of time, like starting now, early and often. The next unit is about 60% memorization, 40% like trying to puzzle your way through things.
Gracious.
Yeah.
That's
So
great.
there's what I want you to focus on in that paragraph, sentence, whatever, is the 60% memorization part. So make flashcards yesterday or something else, whatever, Quizlet or whatever you happen to use. I like physical flashcards because I'm old, but Quizlet's great if you actually use it. You said 9B and 9H?
Yes.
Okay.
H, I don't know why I put 0, but I'm sure I have a reason for it.
So we are supposed to find the inverse cosecant of, not negative. One of them's negative in there. Square root of 2. Okay. What is cosecant in x's and r's and y's and all that stuff?
Is it x over y?
No, that's cotangent.
I just forget which one goes with which.
Sine is y.
Sine is y over r. That's true.
So cosine would be r over y?
There you go. That's exactly what you do right there. Don't even worry about memorizing the reciprocal ones. Just memorize the other ones and then flip them. It takes half a second longer, but it's so much less that you have to keep in your brain.
Yeah.
So this would be r over y. So y is 1. So up 1. So could be one of these two. And there are some problems. So this is 1, and this is the square root of 2, or this is the square root of 2. There are some of the problems on here where it could be one or the other, where there's both possible. We'll because we're taking questions on this, we'll decide whether this is one of those or whether it can only be one of the things. So we gotta figure out what the angle is. It is 45. 45 degrees. Or if you prefer, which I do, but you don't have to, it doesn't tell you what to do, pi over 4.
And how do we know that it's 45 degrees?
Because that's when cosecant is square root of 2. Your chart. So where is the places that is square root of 2 on your chart? On sine and cosine. Just let's focus on sine and cosine.
Square root of 2 over 2.
Okay.
Cosine is 45 degrees.
Okay, so 45 degrees. So square root of 2 over 2. Now, square root of 2 over 2 is 1 over the square root of 2, right? Rationalized. That's where that square root of 2 over 2 came from. So we flip this over, and it's square root of 2, so 45 degrees, or pi over 4. It could also be this one. What would this one be? This. No, it's not negative. Now you could write it negative.
135?
Oh my gosh, you and your degrees. Yeah, it's so much easier to think in radians, y'all. Like, and this is an every year thing. Like I say this every year to people, and it's fine. I get it. You've been doing degrees for a long time, and so it's kind of like feet and inches versus like the metric system. Just move the decimal place over. Metric is so much easier. Radians is like so much easier because the reference angle is going to be pi over 4. So 1 minus a fourth is 3/4. So 3 pi over 4, enter. That's so much easier than 180 minus 40 this and the carry that. Oh my gosh, that's so much more trouble.
You just start a riot so we can get the school system to teach us radians at the same time as we got taught.
Right, right. That might be a little bit much because they don't even know really what pi is at that point when they first start learning about degrees. They don't know about pi. They don't know about what, I don't know.
At least a little bit earlier.
Was 135 right though?
Yeah. Yeah, 135 degrees would also work. Great. What else?
Number 4, you just crossed out my answer for -2. What did I do wrong here?
I don't know.
Was it a calculator error? Or, well, did you just,
Let's do number 4.
does it look like, did I do everything right and then the answer was just wrong? So like a calculator error?
Oh yeah, probably. Yeah, probably. Yeah, that was true on multiple of yours. Like, where I think maybe your calculator was in radians.
Okay, so I'm still confused on when I have to care or not. When I'm gonna have to care if my calculator is in radians or not.
Well, if you're doing trig function of angle and the angle's in degrees, then it has to be in degrees. If you're doing trig function of angle and angle is in radian, then it has to be in radian.
Well, I haven't used my calculator since the class.
Well, that doesn't mean you didn't switch back and forth during the test for different problems, but we can do number 4 real quick. Yeah, let's do number 4 real quick because there was some issue a little bit with whenever you have to divide stuff on those, unlike number 4 and number 1.
I forgot to do this. Oh, no. Wait, no. How do you turn back reads? I haven't done this in so long. I wasn't reading.
That's something that I like. On all the graphing calculators that I've used, it is absolutely the best on the HP Prime because you just click the little corner thing where it shows degrees or radians and then click the thing. So it's great. It's a great calculator. I think if I could only have one graphing calculator, that would be the one I would pick at this point. That's a great calculator too. I'm glad that calculator is as great as I thought it was going to be. Okay, so we're supposed to find the value of x, and we're given this schmogoigle right here. This is x, this is 67 degrees. This is 63 centimeters. What trig function is this?
This is, oh crap.
It's not oh crap, that's not right.
I used to know this. It's cosine.
It is cosine. Adjacent, hypotenuse, cosine. You could use secant if you wanted to, but you know why. So, yeah, cosine. So the cosine of 67 degrees equals adjacent over hypotenuse. How do we solve for x now?
Cosine of 67 equals x over 63.
Yeah, I wrote that. How do we solve for x now?
We have to get rid of
Multiply
this.
the x.
Yeah, well, not the x, but the 63 is divided into x, so multiply both sides by 63.
Oh, one more?
Because we have to get the x by itself.
I did the x. I figured out what I did wrong, Sean.
Okay. All right, and then you push 63 times cosine of 67, enter. And you get whatever you get. I don't even know.
And then that's the answer?
And that's the answer.
Okay,
But then we
nice.
have to round to the nearest.
Yeah, now to the nearest hundredth. It's like something 0.71, I think, if I remember right, but I don't know.
Yeah, 0.62.
Okay, that's fine. What is it?
24.62 is what it comes out to.
2 centimeters.
We.
Great. Easy money. What else?
I don't know why I wrote inches. Other than that, I got pretty close.
That's funny.
I got 24.61 on the test. Did you count that right, or did you?
Yeah.
It's not rounded, I guess. Pretty close.
Why does 4 say round to the nearest degree?
What?
Wait, never mind. Wait, when it says round to the nearest degree, you're dealing with a
Degree. An angle.
And then when it says round to the nearest hundredth, it's the angle.
Yeah.
Can we do 3?
Yeah, we can do 3. Ooh.
So on this one, would it be 25 centimeters since you have to round to the...
What?
On 4, would it be 25 centimeters?
Oh, that's just a typo. You're not even solving for degrees.
So do you have to round to the nearest?
Whatever you rounded to on number 4, you'd probably get it right because there's a typo. So,
Well, you counted off and you told me to...
oh, well, remind me later and you can have the point back, which might change your grade.
Not much. I have to do Dutch corrections anyway.
What are we doing? 3? 3. Okay. So, x. What trig function is this? Sine. We're looking for the angle, so what do we need to use?
Sine x equals 15/88.
Well, okay.
Looking for the sine, the -1.
I've got inverse.
Inverse sine of 15/88. And then enter.
9.81.
And you round in the nearest degree and get 10.
Nearest degree.
So yeah, that probably was a calculator error. Because I did that right. I even had the inverse sign. And it just didn't come out right. Or I put it in wrong.
So
Maybe I didn't put inverse sign.
On 4, we were told to round to the nearest degree as well.
4 is the one where I just said the rounding is like there's a typo. So if you got counted off for where you rounded on number 4, you should see me later and I'll give the points back. Because number 4 was broken. Any other questions? No? Great. Okay, so let's get started on the best unit. Let's do it. Lesson 1 from this unit is easy, so, you know,
Yay.
enjoy it while it lasts. Yeah. She's not feeling good.
It's nice and convenient that we're doing a very hard unit. I learned poems week.
I don't know that this unit is necessarily hard, but there is a lot to memorize.
I'm very bad at memorizing, so it's probably going to be decently difficult for me.
Well, yeah, that makes sense. You should start using flashcards like today. Because then your ballet buddies can quiz you on the flashcards throughout the week when you get moments of downtime.
This unit,
Because I bet you anything, there's a handful of little apprentice or échappé or whoever people that will be like, sure, I'll help you, and they would love it. Okay,
this unit 6.
Unit 5, Lesson 1.
So 6.
What?
It's 6 on here because you said.
Oh yeah, if you did it that way, yeah, that's fine.
Am I out of paper?
Uh-oh.
Do you have an extra? I just ran out of paper.
Yes, I do.
Trig identities.
There you go. Take all my paper.
Whoa. I can get some. I have some more.
I don't like that.
At present. Now I always go back and forth in my brain about this. But at present, my leading theory is that you will not get an identity sheet on the test, so you have to know them. But I might change my mind.
Okay.
So plan on memorizing them, but we'll see what happens. Okay. So these first ones you already know. It's one of the reasons why this beginning lesson is kind of a little bit easy, because we start out with stuff that we already learned last lesson. The reciprocal identities.
How many are there?
Lots. Oh, of specifically reciprocal identities, there's 8.
Oh, like,
Lots.
How many are we writing down here?
What?
How many identities are we going to write down in this lesson?
8 plus 3 plus 6 more plus another 6. Yeah.
Great.
Reciprocal identities. And what I like to get all the identities first and then go back and hit examples after. So these we already know. The sine of theta equals 1 over the cosecant of theta, right? Cosine of theta equals 1 over the secant of theta. The tangent of theta equals 1 over the cotangent of theta. The secant of theta equals 1 over the cosine of theta. The cosecant of theta equals 1 over the sine of theta. The cotangent of theta equals 1 over the tangent of theta. And you also know these already. The tangent of theta equals the sine of theta over the cosine of theta. And by that logic, the cotangent of theta equals the cosine of theta over the sine of theta. Right? Those we know all those. Easy money, right? So I'm going to be giving you strategy advice along the way for solving problems. So this is kind of like, and I think I already used this comparison before. This is kind of like when you're learning to balance equations in chemistry, where at some point you just got to YOLO and try stuff. But there are some strategies that can kind of help make it easier. It's like, well, maybe try this, right? Like weight on the oxygens, right? In chemistry. Your first sort of strategy that is often useful is to turn everything into sines and cosines. And you'll do that with these. Well, and there's actually some others that we've got in a minute, right? So if you're trying to simplify something or whatever, and you have stuff with cosecants or secants or tangents or cotangents, turn it all into sines and cosines. Because if you can get it all in sines and cosines, then there's other identities that you can work with. Okay? So that's your first group of identities. That one's easy because you already know it. The next group of identities is based on the Pythagorean theorem. And so they're called, get this, the Pythagorean identities. The first one is an identity that you're going to use all the flippin' time. All the time. So even if I do give you a formula chart, memorize this one because it's going to show up all over the place. And that is that sine squared plus cosine squared equals 1. A note on notation. This means this. Which is a little bit confusing, because inverse doesn't mean inverse or sine doesn't mean 1 over sine. So unless it's a -1, well, unless it's negative, we're not going to deal with that much, but then you can write this shorthand, which is this is kind of confusing shorthand, but I think you'll get used to it. Okay. So we can also write Pythagorean identities with the other trig functions. Tangent squared theta equals, oh no. Yeah, I could write it that way, but that would be dumb. Tangent squared theta plus 1 equals secant squared theta. And then cotangent squared theta plus 1 equals cosecant squared theta. And if you turn everything to sines and cosines, then this is the only one that you're going to have to use. Although sometimes it's nice to know these. It'll save you some time.
Tangent squared theta plus 1. This makes me look a lot smarter than I am.
So you're writing down all kinds of cool stuff.
Why does that exist? Why does sine squared of theta have to? Why does
Laziness.
why can't they just put sine theta squared? Like you had wrote it there all the time.
Because it takes more work to write that. You have to put the parentheses and stuff.
Okay.
Okay, so let's do some examples of these. We're going to kind of tweak the way I usually present this material because time, and trolley
So
wait
there's
for
just
no
2
man.
identities, right? Or are you calling this a lot more than 2?
That would be 11 different identities.
Okay.
Are you keeping track of the numbers?
No, I shouldn't know if you consider this. Like,
Oh, like when I was saying earlier?
Yeah.
Yeah, no. Yeah, I see. Okay, so start out something simple. If the secant of x equals 5/3, find cosine of x. What's the answer?
So we need something that goes between secant and cosine.
Yep.
Huh?
So would it be in the reciprocal
Yeah.
identity?
They're reciprocals of each other.
Fourth one?
Secant and cosine are reciprocals, right?
Oh yeah.
Let's do one that's a little harder. If the cosecant of beta equals 25/7. Supposedly generation beta happens this year, right?
Yeah.
Whatever that means. And the secant of beta equals 25/24. Find the tangent of beta.
What the? You wrote
Cosecant, secant, tangent.
So cosecant.
It's like a cool cursive R.
It's a cool cursive S.
So cosecant's the reciprocal of secant.
Yes. No, cosecant is not the reciprocal of secant. Cosecant is the reciprocal of sine. So there's sort of two ways to approach this problem. This problem you could approach using identities and like turn everything to sines and cosines, so and whatever else, and try to do all that. You could also try to write tangent in terms of secants and cosecants, right?
I have an idea.
Or what's your idea?
Flip them both, turn them into sine and cosine, and put them on top of each other.
You could do that. Or I think in this particular problem, it's easier to do it this way. What is cosecant?
The opposite.
Hypotenuse over opposite? So 25, 7. What is secant?
It's
The reciprocal. Wait.
It's reciprocal of what? Cosine.
Cosine,
Yeah, which means it's what? Hypotenuse over
Sorry.
Adjacent.
I have
adjacent. Hypotenuse over adjacent. So what's the tangent of beta?
The opposite over adjacent. So that's,
Opposite, yeah, opposite over, yeah.
So it's 7/24.
7/24. Now, if you do it with identities, tangent is sine over cosine, which would also mean that it is cosecant over secant, right? So you can go 25/7 over 25/24. Flip the bottom one and multiply. Or did I say that backwards? I think I did that backwards. What did I do? Tangent, this is later. Of beta equals sine beta over cosine beta, right? This is true because identities, right? Which would mean this is 1 over cosecant. Oh, I did do it backwards. Secant beta over 1 over cosecant beta. Secant beta. Which means it's secant beta over cosecant beta. So it's this one over that one. So 25/24 over 25. Wow. 25/7. Flip the bottom one and multiply. Get 25/24 times 7/25. What happens to 25s?
cancel.
They cancel. So the answer is 7/24. So either way, you get the same answer, yeah?
But that was a lot more complicated.
Yeah, but get used to it because this is your near future. Very near. Okay.
That just has to do with like the chart though, right? Just what tangent.
This has to do with chart. Oh, this is identities.
Well, yeah, but on the chart you find it by subtracting the sine from the cosine, and then you get the tangent. So is that kind of what you did there? It's like when you're writing out the chart to find tangent, you take the
No, you do sine divided by, not minus.
oh.
Yeah, because that's this identity. Okay.
Yeah, I definitely like the triangle.
Okay. If if the cotangent of theta equals -3 and cosine of theta is less than 0, find the cosecant of theta and the tangent of theta.
Is that just the reciprocals of those two, right?
No, it's reciprocals of this, but not reciprocals of this.
So draw a triangle.
I think that I would look at this information and I would try to get some frame of reference from where I am. What am I talking about? What am I saying?
It's a fraction.
No?
Oh.
I mean, it might be,
In the
but
quadrants.
yeah. So I want to know where I am. So cosine theta less than 0 means cosine, in English, that would mean cosine is what?
Cosine's on the left.
It's negative, so it's x. So yeah, we're over here somewhere, right? We're in quadrant 2 or quadrant 3. Now, cotangent is -3. What is cotangent?
Opposite tangent.
-3.
That's a cos over sine, right?
This is what I'm asking.
Okay. Cotangent's x over y, right?
True,
Okay.
true. So where is it not? This one or this one?
It's not in, what is y equal? Which one is y?
Up and down.
Well, yeah, but is it tangent or sine?
Oh, it's a cosine is the, what are you saying?
Well, does y equal cosine or sine?
Y, cosine is x over r. That's how we know it's to the left.
It's whatever one makes the y negative.
If this was negative and this was negative,
It'd be positive.
it'd be positive.
So we're in the, not in the top one. Because sine can be positive.
Well, our answer is negative. Cotangent of theta is negative. So only one of them is negative, not both.
Okay.
This one is, which means x is negative.
That's
So y is not also going to be negative. So it's somewhere over here, right? Got some frame of reference for things? Great, good. Okay. Now what? Now what information could we use?
Could you define referencing?
What if we use a Pythagorean identity? What Pythagorean identity has this one?
That's which one?
This one.
Cotangent squared theta plus 1 equals cosecant squared theta.
Ooh, look at that.
Oh, looky there.
Looky there, we got cotangent, we're looking for cosecant. We could get there from here. Because we know what cotangent of theta is.
So the cosecant.
So it equals -2. I'm gonna square it.
What's -3 squared? 9. What do we do now?
Add.
Yeah, so 10 equals the cosecant squared theta.
Then we have to square root both sides.
We have to square root both sides. That's true. So the cosecant, now pay close attention here. The cosecant of theta equals plus or minus the square root of 10. So we need to figure out which one we're keeping. Because we've identified there's only one possibility because of our conditions, right?
So it's
Cosecant is what?
cosecant is the opposite of it's r over y.
R over y. Is y positive or negative?
Positive.
Positive. Okay. That's good. Let's keep going. That's great. I love it. Thanks, Bree. We have more identities to talk about.
Sorry.
We have some cool identities that I don't really like, and I only used them in one class in college. Because these identities let us delete phase shifts.
Oh, for just.
Oh.
And I spent, these identities are kind of annoying. They were kind of annoying in this one class I took in college because you spend all this time in high school and then in college doing what we did last unit, and you learn how to do the phase shift and all this crap, and you draw it, and you have to do all this pain of subtracting numbers and lining all this stuff up. And then one of the first things that did in this class where we're actually using trig functions, it's like, yeah, the first thing you have to do is remove the phase shift. Why did I waste my time learning that? That was dumb. Anyway, so cofunction identities.
Cofunction.
Yes. This is still the same lesson. This is just more identities. That might change, probably will.
The being easy part?
No, the homework.
Oh.
I mean, it'll get longer, so yeah, it won't be as easy anymore. Okay, so